Since the dawn of time, we've been obsessed with pushing new innovations in learning and applying the skills developed by our predecessors. From electric fields to food, we've conquered it all. And now we've the power to answer bold and daring questions like, how much sauce could you fit on a pizza? So the other day, I was out with a friend, and we were wondering, would it be better for us to buy a pizza each or to pool our money together and buy one larger one? Well, let's look at it. Let's say we were to each buy a 7-inch pizza. That's a radius of 3.5. And using our friend for the area of a circle, pi r squared, we get an area that's about 40 squared inches. But if we put our money together and buy a 14-inch pizza, that's a radius of 7 and an area of almost 160 squared inches between us, so it's about 80 each. But that's still twice as much pizza. So my point so far being that if you want to calculate something like the size of a pizza, it's really just a matter of the size and shape of the pizza. And that's a whole lot easier than calculating every drop. Now, let's step it up a notch. Let's say instead of pizza sauce, it's something like electric field. And counting every drop of electricity looks something like this, where that E is your type of electricity, and that dA is your proverbial pizza size. And that is epsilon. He's very important. He's the magician behind electricity. Really, he's a number that comes up a lot that the universe has created to balance everything. And so we get to a surface integral. And don't worry if you don't know what that is. It's a lot like finding out how big a pancake is by covering it with Nutella, with a needle. And so this is electricity. But when I tell you the word electromagnetic wave, alarm no bells better be going off in your head for 2 reasons. 1, light is an electromagnetic wave. 2, electricity and magnetism are 2 sides of the same flipping coin. So when I show you this equation, which is the same thing, but with magnets, you won't be too repelled. So there's nothing too exciting here and all with that 0. But an interesting thing happens. Oh my God, I'm showing 2. An interesting thing happens if you swap that A for area with an L for length. And now we're getting something. We have a current in the wire and mu. He looks like a U, but also an M. So we call him mu. True story. He's epsilon's best friend. Anything epsilon can do, he can do too, except for magnets. And now continuing with our whole electricity and magnetism, our eternally linked malarkey, we get to our final equation. And there we go. We have it. The 4 Maxwell equations, describer of the world and everything in it. Don't believe me? I'll prove it. So when you're going down a water slide, gravity and the water behind you push you down together. The same thing happens to electromagnetic things, like light. Their electro and their magnetic forces are equal, and they push against each other like this. And that speed you can calculate. It's 1 over the square root of epsilon times mu. Classic. The dynamic duo back at it again with defining space and time. So that number is 299,790,458 meters per second, the speed of light, the most important number in the universe. Like we said, results may shock you.